Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, August 21st. Looking at significant wave heights for the South Pacific Ocean, we see a little bit of something, a little gale trying to organize in the Southeast Pacific, but more noticeable is this storm right off the tip of southern Chile, completely out of our forecast area's swell window and of no interest to us. Otherwise, a pretty benign pattern remains in play over the South Pacific. First up, we're going to take a look at sea heights for the South Pacific Ocean for the past week, actually starting only Wednesday of last week. There was a small gale passed under New Zealand here, really into Thursday, 30-foot seas over a small area aimed east into Thursday evening with 29-foot seas fading out Friday the 19th in the morning. This is good for perhaps a very, very small pulse of swell into Hawaii and the U.S. West Coast, but we're talking barely rideable, nothing more than that. Notice this other gale here, barely in the swell window, but it's all falling south and of no interest, and we'll just roll this out and you see into Sunday, nothing else of interest was going on. So, with that, there's only one tiny swell in the water pushing our way, other than the swell that's already hitting California. Small swell, but rideable. Actually, a little bit more than small, but still rideable. Good for another day or two's worth of surf, but by later Tuesday, it will be fading out. Now we start looking towards the future. What's to come? First off, as usual, we check out the jet stream. Jet stream level winds up about 30,000 feet. Helps to support the formation of gales when those gales do form. Helps direct their track. We see a trough right here. That is a dip in the jet stream. Really, it's a push to the north in the jet stream. In the southern hemisphere, right here, the ice line is varying between 60 and about maybe 64 down here. So this sort of looks like a trough here, but it's all over Antarctic ice. No swell generation potential. This trough here looks like a gale could be organizing here in the Southeast Pacific. The cutoff for Northern California is about 120, 122 west. For Southern California, about 118. The jet stream tends to precede what's happening at the surface, so your trough might be here, but down at the surface, the low would maybe be a little bit behind it over here. Anyway, that's the major feature. Split jet here, high pressure in between those two streams, nothing going on. We're also going to watch this little area here, see if anything were to materialize of it. So we see our original trough fading out by Monday night. And again, there's sort of this troughy feature, you know, little waves working their way to the north, but the ice line again here is there. So it kind of shuts it down till we get into, let's see what happens here. Then we get into where we are. Thursday morning, another trough is forecast to develop here in the central South Pacific. 120, 110 knot winds pushing north for just a very short period of time. And that quickly falls apart. Then we get this ridge pushing to the south. That only supports high pressure aloft on Friday. And that sort of continues over the South Pacific into Sunday, and you just see this big ridge mashing south. Little bit of a trough tries to organize here under the Tasman Sea, though. 18Z on Sunday, that's a week out from now, and gets a little bit better foothold into Monday. But again, a week out, don't believe that for a second, but maybe there's some hope there. Let's take a look down at the surface. So here we go, surface level pressure, surface level winds. We did see a trough right in this area, and sure enough, there's a tiny, just a infinitesimal little gale here with just a, 100 nautical miles of 45 knot winds. That's as of 18Z. A little bit more southerly flow by the 0Z run going into Monday and lifting more to the north, but starting to push out of the California swell window. That maybe is good for a little tiny pulse of swell. We'll find out in a minute. Otherwise, yes, we see fetch here, but again, the ice line's down here. Not looking particularly promising. We'll roll this out. Now here's a gale, but again, this looks like for the most part, it's 948 millibars, very low, deep low, but again, mostly over ice would be the assumption. Pushing to the east and maybe reaching above the ice line on Tuesday into Wednesday, but just barely. Roll this out further. We knew there's another trough in this area here. I forget, it was in the Friday-ish time frame. Now notice there's a gale here, but it's supposed to be falling south. That's of no interest. Notice all the arrows here for this fetch aim to the south, of no real interest. Nothing going on. Then here we get into Sunday. We're a week out. We'll go back here. Saturday night. 45-knot winds developing in the Tasman Sea over a pretty good size area. Another tiny little patch of 55-knot winds there, and getting more organized and cohesive so that by Sunday night, that is a week out, a rather broad storm is to set up. One would love to get excited about this. We don't think any of it's true. Way too far off in the future. If this is still here, or even some various incarnation of it, 4 to 5 days out. So we're talking, maybe, let's say Tuesday or Wednesday if it's still on the charts for Sunday. Then maybe we have something to get interested in. So follow the charts and sort of monitor it for yourself. Otherwise, we'll update next week. So from the surface perspective, not a whole lot going on other than that one tiny little gale that's forming right now. Let's go take a look at the wave model chart and see what it all means. So here we go, the current chart. There's our little tiny start of the gale. Sunday night, 30-foot seas, I guess, so over such a small area, 32 feet. And by Monday morning, yes, 32, maybe 33 feet, right on the hairy edge of the Northern California swell window. Still better in the Southern California swell window. But because the area is so small, whatever swell you're going to get would be rather inconsistent and just not really impressive at all. But at least there is some little hope of something in the water. The system fades out and moves out of the swell window, targeting mainly Peru and Chile thereafter. And given that they're closer, there'll be less swell decay, and most of the energy is aimed in their direction. So they stand a reasonable chance of getting something that looks like real surf. Now here we go, this Wednesday system, but way to the south. It is off the ice line, barely 30-foot seas, and then moving out of the swell window and kind of falling southeast, of no real interest in effect. And then the next opportunity is, here we go, on this one a week out, 34-foot seas building into, what is that, 46-foot seas right there, 46.5, and pretty well positioned for North, South California, and Hawaii for that matter. If one were to believe the charts, none of this is believable at all, but it's a nice tease. Let's go take a look at the Northern Hemisphere. So here we are, significant wave heights for the North Pacific Ocean. We see some sort of tropical something or other going on here, but again, very small in size. Let's see if there's any. And the path is into Japan. No energy radiating. The Great Circle Pass to Northern California are basically that. So you need something pushing up like that to get across. And no hope of that. We'll just roll through this. We already cheated and looked. There's just nothing really going on. Now, again, when you get out about a week, the charts start teasing about some sort of tropical development here in the far West Pacific. And we'll just take this a little bit further. And you see, here we go, 168, we're talking 44-foot seas in this thing. It's completely gray here because the isobars are so tightly packed, meaning it's a very small area. Yeah, still 46-foot seas, but again, the GFS model, that's really what's driving this. Notoriously bad for resolving tropical systems, and especially tropical systems a week out. So completely unbelievable, but something to watch. It would suggest that perhaps the Northern Hemisphere is starting to come alive. If this system can do a track up like this, swell could result. In fact, we actually had a little swell last Thursday in Northern California. By little, we're talking, I don't know, was it 4 feet at 11 or 12 seconds, something like that, from a tropical system that Omeus that went up here into the Gulf of Alaska, actually fell, through the Bering Sea, into the Gulf, fell into the Gulf of Alaska with maybe 18-foot seas and quickly dissipated. It was about a day and a half of, I'll call it wind swell or protus swell or something. You know, rideable, but nothing more. But we are in the season. About August 15th is when we start looking for tropical systems to recurve and starting to get some swell. That's only on the best of years. We don't expect this to be the best of years, but you never know. That's a benchmark to use to start monitoring. But for now, the focus still is the Southern Hemisphere. Unfortunately, it's kind of anemic. So next we look long-term beyond the week event horizon into weeks and months, specifically the Madden-Julian oscillation, seeing whether that'll help support gale formation or storm formation. Then, of course, La Nina, minimal at that. Let's get into the details. First up, we like to monitor winds and wind anomalies in the Kelvin wave generation area. Here's New Guinea. Date line is right here. The equator, East Pacific, West Pacific here. Kelvin wave generation area runs from about 170 over to about 135 and 5 degrees north and south of the equator. You notice actual wind speeds are from the east here. What we want to see is no winds in the Kelvin wave generation area, which this is suggesting. This is not a model. Again, this is data from the TAO buoys on the ocean surface. Where there is no data here, the buoys are out of operation. But what they do suggest is strong easterly winds to the date line, and then you get in the Kelvin wave generation area, and winds back off considerably. Anomalies here, differences from normal for this time of year, suggest a normal. These strong easterly winds are normal for this time of year in this region, and the lack of wind here shows westerly anomalies. So that's actually a good thing. This is maybe a hint of the active phase of the MJO. And the Madden-Julian oscillation, when it produces westerly anomalies, again, here's another chart. This is back about 5 days ago. Right here, it's this little area right here. And that, when you have westerly anomalies in there in the active phase of the MJO, that tends to goose up the jet stream in the North Pacific in fall and winter months and helps support storm formation over the date line and into the Gulf of Alaska. So just sort of looking at the trend here, these oranges and yellows suggest weak westerly anomalies, and that continues maybe even a little bit weaker on the 19th here, but still suggests some sort of sense of some weakness towards the active phase of the MJO. Here's another chart. These are 850 millibar wind anomalies up about 4,500 feet. Another good proxy for what's going on down at the surface. Kelvin wave generation area, 170, so 170 west to about 135. So this little band right here, this is the whole planet on one chart. The Pacific is just one slice of this, and the Kelvin wave generation area, a smaller slice of that still. So we see the oranges and yellows are suggestive of westerly anomalies and perhaps the active phase of the MJO, but notice there's these easterly anomalies that kind of show up at the same time too. The active phase of the MJO per this is supposed to pretty much start dying out in about 2 or 3 days, and then easterly anomalies take over, suggestive of the inactive phase of the MJO. All the real energy here is in the Indian Ocean, pretty typical of La Nina, and we'll show you why in a couple of slides from now. Another way to search for the active phase of the MJO is these charts, outgoing long wave radiation. The blues and darker blues here suggest less sunlight or less reflectivity off the ocean surface, suggesting more clouds, suggesting the active phase of the MJO. Oranges and yellows suggest more sunlight reflectivity, synonymous with high pressure, and the inactive phase of the MJO. So this, per the statistic model, suggests the active phase of the MJO is in fact in the Kelvin wave generation area, and it's to slowly fade over the next week and then fade out completely. The dynamic model suggests something different, suggests that the active phase of the MJO is in fact supposed to hold over the West Pacific for the next 2 weeks. That would be a good thing if it were true. Notice there is a definite discrepancy between the statistic model and the dynamic model. So outcome is, we'll call it 50-50 at this point. No one really knows, but for right now, the active phase appears to be in control. Another way to look at this is using phase diagram charts like this one right here. Assume you're looking down on the North Pole right here, and then the active phase, or the MJO, be it inactive or active, rotates counterclockwise around the chart from the Indian Ocean over the maritime continent to the international date line, into the West Pacific, over into the East Pacific and across the U.S., into the Atlantic Ocean, and then over Africa and Europe, and then back into the Indian Ocean. Only on the equator here we're talking. The big dot is where the active phase of the MJO is right now, on the date line. The further away, so the circle is the dead zone. If your dot is in here, it's so weak it's negligible. We're out from that. Let's call it a weak to modest active phase of the MJO. The green dot suggests the track over the coming days. So basically, the next 2 weeks oscillating somewhere here through September 4th in the active state on the date line. And the GEFS model also suggests very much a similar pattern, maybe not quite as strong. All these bode well if the active phase is in control, especially for tropical storm development in the West Pacific, and especially for helping to push those systems to get them to recurve to the northeast and eventually move towards the Gulf of Alaska. Again, it's kind of early in the year. El Nino is not in play. We do not have high hopes for recurvature, but the atmosphere isn't biased against it per the MJO forecasts. And one final model, the CFS model, up about 850 millibars, 4,500 feet up. Here's the current time, past history here, future forecast here. Westerly winds, Kelvin wave generation area, 170 through about 135, so this region right in here. And we see westerly anomalies in play in the West Pacific Ocean. We'll just overlay this. Now notice it's supposed to fade out, little pulses, active phase of the MJO, the solid contour is the active phase of the MJO, holding over the Kelvin wave generation area into about mid-September, then a very weak inactive phase, but notice westerly anomalies, these yellows are still kind of holding in this area somewhat, and just notice these active and inactive phases are very haphazard, not very strong at all. Suggestive of just a very weak MJO pattern, not a lot of fuel to support storm development, but nothing actively pushing against it either. You notice westerly anomalies still holding. You could literally almost draw a line right down here, and that's about roughly on the date line. So weak westerly anomalies to the date line in the Kelvin wave generation area. Forecast at least until mid-November with easterly anomalies over in the East Pacific, but that's not so bad. That might not do well for precipitation in California, but in terms of swell potential, nothing, actively suppressing it or nothing forecast to actively suppress it through mid-November. So that's a pretty good sign. So we could say the MJO is active, weakly so, and expected to stay that way in some flavor for the foreseeable future. One goes, great, that sounds wonderful. Well, yeah, but let's take a look at what's going on in the ocean itself. Actual water temperatures, West Pacific here, East Pacific here. We see warm water balled up in the far West Pacific. That's pretty typical of La Nina, and not so warm water in the east. If we were in El Nino, as we've said before, all this warm water would be moving over here, and there'd be less warm water over here. Differences from normal for this time of year, and again, this is a profile down into the ocean, down 300 meters into the ocean. Here's actual from buoys. Here's the actual buoy anchor line, sensors on the anchor lines. The array looks to be in pretty good shape, suggesting, yes, in fact, 1 degree anomalies in the West Pacific. If you want a really good storm production, you want to see warmer water here. We're not seeing it. If anything, we're seeing 1 degree below normal anomalies in this kind of thin stream, making it the whole way to Ecuador. At the surface, normal at best, maybe a little bit below normal, and a little bit of a upwelling thing going on here at, where is that? That is about 150, so south of Hawaii. This is pretty typical La Nina. No signs of any Kelvin waves, nor is there any way for a Kelvin wave to organize, even if you did have westerly anomalies of magnitude here. This is just the typical rebound from El Nino, which is called La Nina, and it's characterized by cool subsurface water, and that cool water advecting to the surface or upwelling to the surface. Another high-res version of the same sort of chart showing this exact same picture. Warm water in the west, cool water filling the Kelvin wave travel area, and not offering any chance to really get warming going on in the East Pacific. Upper ocean heat anomalies is the top 300 meters of the ocean surface, and you can see last year, September, this was a very warm Kelvin wave. Here's your anomalies, 2.5 degrees above normal. Kelvin wave, I think it was Kelvin wave 4, Kelvin wave number 5, Kelvin wave number 6, and then that was it. There was nothing but cold water left in the far West Pacific Ocean, so that water eventually started migrating to the east, and there you go. You have La Nina. That's what we've been suffering through. It sort of stopped here a little bit in late July, but now in August it's starting to organize a little bit again, but not particularly strong. I mean, this is not by any means some sort of a massive La Nina. If anything, it is very weak and very minimal, and we should be thankful for that. Next, we take a look at surface ocean temperatures, deviations from normal. Here is Peru. Here is Ecuador. We see just the thinnest little slice of cooler water along the coast here, radiating off, going over the Galapagos, only a degree or two north or south of the equator. It doesn't really start to bloom till you get out to about 115 west, so this would be south of mainland Mexico, and then the real La Nina signature starts to appear with cooler than normal waters, these blues. Here you go down into this here, the minus a degree to a degree and a half, let's say, or so. Going to, what was that, about 8 degrees north and 5 degrees south of the equator. And the last little lingering pockets of El Nino warm water are slowly fading out, being destroyed or negated by cool subsurface water advecting or upwelling to the surface and then getting advected off to the west by the easterly winds that we saw in the previous charts, pushing all that warm water off to the west. Trend for the next 7 days, or for the past 7 days. What's the water temperature been doing? Well, the reds actually suggest that we've been getting some warmer water in this area, that temperatures are warming, and we've actually seen that in the charts. The flow off of Ecuador has pretty much choked off, and then we have little pockets of cooling and warming. This has been the pattern all summer, but pretty much an even distribution of both for right now. We often look out for Africa to see if there's a trend here. Nothing really going on. Last week I think it was a little bit warmer than normal here. And that whatever you see over here tends to manifest itself a week or two later off of or in the East Pacific. And so we are seeing that warming occurring here. If we start to see a big blowup of cooler water here, then we know La Nina will pulse again. But for the moment, it is not pulsing. And then finally, the overview picture, what's going on. Clearly, you can see the La Nina cool pool in the main Nino 3.4 region, which runs from 120 to 170 and 5 degrees north and south of the equator. So right there, clearly, cool waters are taking control. In fact, you can see the trend right in this chart. Nino 1.2 region is the area tucked up right there along Ecuador and Peru. And the past, was it 2 weeks, you can see warming going on. We're up to plus 5.93. Now, this doesn't really contribute to El Nino. It's the Nino 3.4 region, but it gives you sort of a clue of what's going on in the area of the Galapagos, and we see warming here. And by and large, the trend has been, normal to maybe, let's say a quarter degree above normal, which isn't a whole lot. You'd want to see much warmer if it was El Nino, but considering that it's not down in the negatives, it's no clear sign of La Nina either. Next, we go to the Nino 3.4 region, the area that what you use to monitor the presence of El Nino, La Nina. And since May, you can see there's been a bunch of fluctuating, but in general, the trend tends to be right around neutral. And then in July, we went deeply negative, 1 degree below normal, which is honestly, for a La Nina, not all that negative. Right now, we're playing around somewhere around, we're at minus 0.643, but you could pretty much draw a line through this and say it's about 0.5, which is barely La Nina threshold. Here's the forecast for the Nino 3.4 region. Right in here, about half a degree is what this model suggests we're at. And by October, temperatures are actually supposed to go up to maybe minus 1/3 of a degree or something like that, then fall back down to 1/2 a degree into December, and then start rising, returning to neutral in the springtime frame. If this is the sum total of our La Nina from the El Nino that has occurred, that's a good sign. That is not that much. It's barely, so the La Nina threshold is 1/2 a degree, and you need to run for, three-month consecutive periods. And so we're barely going to reach that threshold. That would be a good thing. This would sort of suggest that the Pacific decadal oscillation maybe is starting to take root, that we're into a change from the past, 15 years, where it's favored La Nina, and certainly the swell over the past 5 years has been, or ocean activity in the winter months has certainly reflected that trend. But if the PDO is changing, then that would tend to mute La Nina and tend to enhance El Nino cycles when they occur. We're in La Nina, by all means, there we were. There was our big El Nino. We should be down somewhere in here, and we're nowhere close to it, so I guess we'll see. It's going to be another 6 months to a year till we know for sure. So here's the mid-August plume from the IRI CPC. This is a summation of all the different models and where they're at. Here's a list of the dynamic models, the statistic models. The chart shows, if you just eyeball it, it was somewhere around minus 0.5 or 0.6 is probably the average. But they do all the dirty work for us. So here's a list of all the dynamic models, month-by-month forecast, statistic models. If you just go to the bottom line here, the summation of all of them, the thought is half a degree, maybe 0.6 of a degree into, what is that? Oh, let's say February or so, and then starting to moderate to a third of a degree. Again, a bare minimum La Nina appears to be in play and appears to be forecast and really not getting any stronger. We're maybe a month out, it'll get down another tenth of a degree, and that's as low as it's going to go. So that would be a good sign if it were to be happening. Another one. So now that we know, we've talked about the MJO, we've talked about the impacts of El Nino, La Nina. But that's all sort of in the ocean. What is it doing to the actual atmosphere? Well, as you can see, here was our El Nino back in 2014. Southern Oscillation Index here, differences in pressure between Darwin, Australia, and Tahiti. A good indicator for El Nino and La Nina. You can see the downward trend in the Southern Oscillation Index, indicative of El Nino. El Nino bottomed out here in the fall of 2015. And then you can see the big upward spike here now. This is the onset of La Nina. But notice, we were down here in the minus 23s or so, 30-day averages. Right now, all we're doing is hunking along in the +5 range. Again, the atmosphere is not very strongly coupled for a La Nina, and the ocean is probably reflecting it more than the atmosphere is at this point in time. Actual hard numbers, today's value 11.53, stronger than numbers have been. Now, we had one of those back in August 10th, but we've also had some negative numbers. 30-day running average, 3.69. That's the chart we were just looking at. And the 90-day running average, if anything, is not really going anywhere. 2.87, and you just kind of look here, and it was actually higher back in July. So it sort of seems like La Nina, at least from an atmospheric perspective, is losing some of its punch. The ESPI index, very much like the Southern Oscillation Index, only it's measuring rainfall anomalies, actual precipitation north of Darwin and then north of Tahiti in these regions. A positive number reflects El Nino, negative numbers, La Nina, minus 1.07 as of the 21st of August. It was actually down to minus 1.5 a week or two ago. So again, this also reflects sort of a weakening La Nina state, at least for the moment. So to wrap it all up, right now there is small southern hemiswell in the ocean in California, but it's starting to die off a bit. Another small swell, one coming from under New Zealand. Very small is the operative word. And another one, forecast small storm, forecast a small form south of California in the next 24 hours. But the resulting swell from that is expected to be very minimal. Other than that, weak active phase of the MJO in control, and forecast to probably stay in some flavor. But, and La Nina's here, but it's weakening too. So we're just sort of in this blasé period where we're not either really El Nino or La Nina, and the MJO's weak. I think we're really just waiting for the onset of fall to sort of nudge things along, but the MJO isn't helping it at all. So that would, when we get in these sort of low energy states like we are, it tends to go on for a while and you don't get a whole lot of activity. Local wind swell is probably your best bet, but even that wasn't on the charts. So for now, just get whatever surf you can, hope for the best, hope the PDO is on its way, and 6 months from now, this will all be a distant memory. Well, I guess we'll see. Anyway, that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.